The Millikan oil drop experiment. Have you ever seen those perfume bottles that have a little pouch, and if you spray the pouch, then like a little mist of perfume comes out? Usually there's a beautiful glass bottle, okay, and then there's like this like membrane pouch, and it's like you put and it puffs out. Yes. Well, imagine that if you squeeze this part right here, okay, the little tube down here and a little beaker thing of oil would spray out a mist of oil, and when the oil came out, it rubbed up against this rubber tubing, this like straw right here, and electrons got scuffed onto the oil. So they were negatively charged oil droplets. And some of the oil droplets had like 1 extra electron, and other oil droplets had 2 extra electrons, and other oil droplets had 3 extra electrons. So you get these oil droplets spraying out of the container. And each little oil droplet was negatively charged. Well, some of these oil droplets would fall through this little hole in the top of a capacitor. And when the oil droplets fell through the little hole, you would be able to see them by looking through like this microscope device, and this is like the person's eye, looking through the scope, at these oil droplets. And normally speaking, the oil droplets would just go right on down. But the fact that they were negatively charged, if this bottom plate down here was made negative enough, and the top plate was made positive enough, the oil droplet actually might stop from falling down, due to gravity, and start to actually go up due to the electrostatic force. So basically, if you took your hand and you work this variable voltage source, you could keep on tweaking the voltage as you're looking through the scope here, and you could adjust the voltage until you get the oil droplet to float right there, to be suspended. Now, if we look at the forces acting on that oil droplet, there's 2 of them. There's the weight of the oil droplet, Fg, and then there's the electrostatic force due to the invisible electric field pushing up on it, F sub E. So if you got the oil droplet to stand still, or to move with a constant velocity for that matter, because if it was moving with a constant velocity, it would still, those 2 forces would be balanced out. So if you either got the oil droplet still or moving with a constant velocity, you knew that those 2 forces were equal to each other. Well, let's take a close look at those 2 forces, shall we? If the electrical force was equal to the force due to gravity, we know the force due to gravity is equal to m times g. The electrical force is equal to E times Q, the charge of the oil droplet. But from that formula, V equals E times D, for a capacitor, we know that the electric field strength equals the voltage divided by the distance between the plates. So we would have the voltage across the plates divided by the distance between the plates divided by Q equals M times G. the voltage was easily measured by the voltage source. You could put a voltmeter on that to determine what that voltage is. The distance between the plates of the capacitor, that's very easily determined. The acceleration due to gravity, that's known, 9.81 meters per second squared. The only troubling thing is getting the mass of the oil droplet. That was a whole experiment in itself. To get the mass of the oil droplet, the voltage had to be turned off, and then the oil droplet would start to drop down, but it didn't accelerate all the way down because of the air resistance. It would reach a terminal velocity, and it turns out that that terminal velocity was directly proportional to the mass of the oil droplet. That's a whole nother experiment in itself. So we're just going to assume that by other means we can figure out the mass. So if we can figure out the mass, we know G, the electric field strength, can be figured out. Then what could be determined about that oil droplet? The charge. So basically, this is what was figured out, the charge of the oil droplet. And I'm running out of time here now, so I'll have to tell you a little bit more about, what was found out when the charge of these oil droplets, was determined. We're actually going to do a little, our second lab. I know I haven't gotten you the data from the first lab. I'm close to that now. But we're actually going to do an online simulation lab based on Millikan experiment after that next lab.